Hi, this is Keith Shabbat, your friend in the mortgage business, and today we're discussing structural inspections. How can you be certain that a crack is structurally deficient? There are generally three types of cracks: vertical, horizontal, and diagonal. However, in this video, we are not going to be discussing every one of them. We're going to be discussing just these three. If you understand the three basic crack patterns outlined below, you will have a reasonable understanding of approximately 85% of all cracks that you will ever see. Let's cover the three basic ones here one at a time. Vertical cracking is not structurally related or deficient unless there is a lateral movement, displacement, bowing, or if the crack is uneven from top to bottom. If the plane of the wall is the same on both sides of the crack, it is typically a contraction crack and not structural issue. Since everything expands and contracts, it is common in commercial work to provide control joints in areas where expansion and contraction is expected. However, control joints are not typically installed in residential construction. Ridged materials, such as poured-in placed concrete, tend to crack from expansion and contraction much easier than more flexible materials. If all loads were evenly distributed on this type of wall, were a consistent thickness and were the same height of the entire length, the vertical cracks would most likely occur at close to the center of the wall. If there is a window or door in the wall, the crack will occur at the opening, as a window or door creates a void or a weakness in the wall. The crack would typically occur in the center of the wall if there were no more openings. The vertical cracking in this situation may be 10 to 15 degrees out of plumb vertical. However, it is still considered a vertical crack. Such cracks are most common in poured-in place concrete or concrete block construction. The rule of thumb to expect vertical cracking if a wall made of ridged material is 32 inches or longer and forms a straight line without pilasters, joints, or other structures such as masonry chimney. First, look at the center of the wall. Unless there is a window, the crack will almost always occur in the window in this scenario. The horizontal cracking as a block construction is structurally related because the bond between the block is broken. However, this does not mean that the wall will collapse. The amount of the movement and the cause of the movement is important issues to consider. Frost, backfilling, or significant unbalanced load may cause cracking. While no cracking is desirable, it is important that you understand the differences. A frost line crack is not likely to have serious repercussions unless the conditions, such as negative grades, are not corrected. Cracking due to poor backfilling practices or heavy equipment close to the walls is usually a one-time occurrence. Movement caused by excessive unbalanced load presents the most serious situation, and failure is progressive. A significant unbalanced load may be destined for collapse. An example: a 4-inch unbalanced load against an 8-inch block wall is the current limit. It is not unusual to build homes with 8-inch block and 6 or 7-inch of unbalanced load in the 1940s and 1950s in many areas of the country. The engineering community suggests that a rule of thumb that is, if a wall is moved a third of its thickness, then the wall is considered to be imminent danger of collapse. This may also suggest that if there is only a half-inch of movement, it is not likely that the wall will collapse. Diagonal cracking. Diagonal cracking is almost always structurally related. Diagonal cracking is defined in this example as a crack that tears through the material, not a steep crack that follows the mortar joints. To understand the source of a cause of a diagonal crack, draw an imagery line perpendicular to the center of the crack down. This should point to the source of the reason for the cracking. Example: assume that a frame floor system is carrying enough weight to cause it to sag, and that the subject wall is parallel to the joist system. The sag would typically be farthest from the bearing points at midspan, where there is likely to be a diagonal cracking. Draw an imaginary line perpendicular to the crack from the center of the crack downwards toward the floor. This should point to the midspan of the floor joists. In the above example, the cracking would typically occur 1 to 4 inches from the corner of the settlement wall. Because the wall that is perpendicular to the settlement wall is likely to be supported differently and resist movement. A wall that is a foundation beam is perpendicular to the floor joists will support better than the wall that is parallel to the floor joists. you are looking at the foundation wall with diagonal cracking, you should be concerned. However, determining that the source is fairly easy, again, draw an imaginary line perpendicular to the diagonal crack and follow the floor. This does not mean straight down to the floor or 90 degrees to the floor. It means that you follow the line on the angle that is perpendicular to the crack. Being able to determine the cause of the source of the cracking problem will be a guide to the action or solution needed. By understanding a number of different crack patterns and their significant causes and sources, the solutions are relatively straightforward. If a design solution may be required, a structural engineer should be consulted for an opinion, options, and a recommendation solution. To learn more about these, you can call one of our mortgage consultants and we can help you out, or you can speak directly with a structural engineer or a home inspector. This is Keith Shabbat, your friend in the mortgage business, discussing structural inspections.